Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss Pascal's law in detail. So we have already studied in the previous video that how pressure changes with the depth in the static liquid, and hence we can say that at two points which are two or more points which are on the same depth from the surface of the liquid, the pressure will be same. So this is the Pascal law, according to which the hydrostatic pressure at same level in a static fluid is same. So to demonstrate this Pascal's law, let us take an example of two vessels which are interconnected with each other, and they are filled with same liquid. Let's suppose it is water. So let us assume 3 points A, B and C which are at same depth from the surface, and at these 3 points obviously pressure at A, B and C will be same, because pressure at all of these 3 points will be P naught plus this is H rho G. H rho G. So pressure will be equal at all these 3 points. I'll write it down here. So PA will be equal to PB will be equal to PC and will be P naught plus H rho G, where H is this depth. Okay, so this is the first thing. And now if gravity is not present, in the absence of gravity, so in the absence of gravity we can say that G will be 0. Obviously G will be 0, and if G is 0, then this term will be 0, and we can say that pressure at all these 3 points will be same. PA will be equal to PB will be equal to PC, and it would be equal to P naught. Okay, so this is the Pascal's law in the effect in the absence of gravity. Now let us talk about a phenomena which is called as hydrostatic paradox. Now the word paradox means in Hindi we say it virodhabas, which means that we see something else and it is actually something else. So we can see that in these three situations the mass of liquid filled in these three vessels will be different. The highest volume and mass of liquid will be filled in this vessel, and but the length of liquid column in all these three vessels is same. Now we cannot I'm not saying that length of liquid column means this length. The height of liquid column is actually the depth measured in the direction of gravity. So as we can say that gravity is acting in just downward direction, so we have to measure this height as h. So pressure, if these three heights are equal, then pressure at A, B and C will be equal, and it would be P naught plus H rho G. This is called as paradox because obviously it seems that the container which is having the highest mass of liquid filled in it would apply the most pressure, most high pressure at the bottom of its container, bottom of its base. So this is not the case in reality. In reality, if this liquid column height is same in all these three cases, then pressure at this same points which are at same level A, B and C will be same. So this is hydrostatic paradox. And if we talk about hydraulic jack, which was firstly called as Brahma's press. So you must have seen that when your car tire get punctured, then at puncture shop, puncture man brings a jack of some red color and put it below the car, and then pumps that jack and car gets lifted up. So this is a very easy process to lift up the car due to this hydraulic jack. So let us imagine that this is a piston which will be below the car, and this is the piston at which we will apply the force. And these two pistons are massless. We are just assuming this, and the atmosphere is not present. So, or atmosphere may be present. It is of no significance, and the area of this piston A1 is very greater than the area of this piston A2. So in this case, if we say that at this point A, and at this point B, pressure will be same, PA will be equal to PB, and at A, pressure will be weight of the car upon area A1, and at B, pressure will be F upon the area of piston A2. So F will be equal to W A2 by A1. Now A2 by A1 obviously is very less than 1. So if A2 by A1 is very less than 1, then we can say that F will be very less than W, which means by applying very less force we can lift up a very heavy weight. So this is the principle of hydraulic jack, which is also called as Brahma's press. Now if let us take an example that if the car is of 1000 kg and this A2 by A1 is equal to 1 by 100, which means that the piston A2 is 100 times smaller in area as compared to piston A1. So to lift a car of 1000 kg, we have to apply only 1000 into 1 by 100, which is 10 kg force. So we can apply a car of 1 ton by only a 10 kg force, which is approximately 100 Newton. So this is the power of hydraulic jack. Now let us talk about the hydraulic brakes also. So this is a drum brake system. Nowadays cars are equipped with disc brake systems, but disc brake systems and drum brake systems are works on the same principle of hydraulics. So we have seen that there is a oil in the car which is called as brake oil. So that brake oil is the key to apply this brake in the car, and there is a piston which is connected in the drum inside the car tire. So when you will open the car tire, there is a drum inside, and inside that drum this arrangement will be seen. These are the brake shoes, and there is a spring which is connecting this brake shoes, and this is a piston. So as soon as we will press the brake lever, this piston which is just below the brake lever will be compressing this fluid inside these 4 tires. This system is connected in the all 4 tires. So when this fluid will be pressed, this piston will engage, this will go out, and these brake shoes will be tightened over the rotating drum, and due to friction that rotating drum will be retarded, and due to that retardation car will stop. And in that case, when the brakes are applied, these brake shoes are opened up and this spring is stretched, and as soon as we will withdraw the brakes, this spring will bring back these brake shoes to their original position, and that would release the brake, and car will now move smoothly. This is the same technique which is used in a disc brake system, because in disc brake system the complete car tire is connected with a disc, and there is a brake shoe arrangement which is tightened over this disc, and as soon as we will press the brakes, that piston of that brake shoe will engage, and it would tight the brake shoes over this disc, and eventually due to friction this disc will be retarded and car will come to rest. Okay, so this is the complete hydraulic braking system, and in the next video I'll be bringing the further numerical problems which are based on Pascal's law. Thank you.